Good morning, everyone. First of all, let me thank you all for being here today. I'm Butsara Sunthorn Vishakan, a master degree student in radiological technology at Michigan University. As you can see on the screen, I'm going to talk about the thesis research in the topic of image matching for radiographic positioning. Beginning of this research start from the program of the Department of Radiological Technology. All students have to learn about X-ray imaging and how to set up radiographic positioning. And experienced students may be harmful from radiation exposure. So, our department has set up radiographic positioning laboratory which is equipped with simulated X-ray machines to eliminate the risk of unnecessary radiation exposure. And to make students more understand about position for X-ray. Thus, there is an idea from CAI or computer-assisted instruction. The CIA can demonstrate various techniques of radiographic positioning and display radiograph according to the selected position. Therefore, the research aims to develop the computer program that will be part of CAI to demonstrate the hand X-ray positioning. This slide shows the CAI for radiographic positioning. An example for positioning of upper extremity are shown. In this, we use radiographic positioning of hand to demonstrate. CAI will show how to position and how X-ray hand display. The objective of this study was to propose a new method to learn radiographic positioning by using an image matching algorithm, which can be used for evaluating the radiographic positioning of hand images taken by digital camera. The hand materials in the research are composed of Microsoft Virtual Studio 2008, digital camera, and 130 volunteers. 130 radiology students at Michigan University aged between 19 to 22 years old were taken right-hand images with a digital camera. Each student were taken 3 hand positions such as PA, oblique, and lateral, which are actually used in radiographic positioning. All these images are bitmap file with the size of 640 by 480 pixels. 130 images of each hand position collected from students were randomly selected as template for 100 images, and the remaining images will be the test images. In this study, we used 3 criteria to differentiate the position of hand image. The first criteria is heightened some value of correlation coefficient or CC. Criteria 2 is thresholding in CC, and criteria 3 is counting number of fingertip. This is conceptual diagram of the first criteria. We start with entering the test image into the program. The program will compare test image with 3 template dataset and calculate CCV. In each position, 100 CC values obtained for 100 template image are summed together. Any template position that provides in the height CC would be assumed at the correct position. The next criteria is thresholding a CC to get an optimal threshold for differentiating hand position. For threshold at 0.6, 0.7, and 0.75 and 0.8 was tested. We found that 0.75 and 0.8 gave high percent accuracy, but they were not much different. Therefore, we select 0.75 at an optimal threshold. This part is similar to criteria 1. The difference is this part. We count the number of templates that has CCV more than 0.75. Any template position that provided the highest number would be selected as correct position. Last criteria is counting number of fingertips. The criterion used the area of 270 times 70 pixels located on the top of the hand in the image to count the number of the fingertip. The hand position can be identified by the following conditions. If number of fingertip is 1, the image is assigned as lateral. If the number of fingertip is 2, the image is oblique. If number of fingertip is 3, the image is PA. Again, the accuracy of this criteria was also calculated. This slide shows the location of 270 times 70 pixels that we use to count the number of fingertip. 3 points detected means PA position. The following parts are the result of the study beginning with template dataset. The effort, CC and SD of each position are shown in this table. The CC values indicate the relationship between images within the same position. You can see that the variation or SD of hand in each position is small. That means hand images of different students are not much different. More image matching. In the result of first criteria, which is height to summed value of the CC, the table shows the pattern of accuracy of this method. Lateral hand position gave the height and accuracy which 100% followed by oblique 93.30% and PA 73.33%. The criteria that shorting in CC, we use CC as 0.75 as the cutting point. The results show that lateral and oblique gave the accuracy of 100% and PA gave 85.33%. Last criteria, counting fingertips. This method is used number of fingertips to identify hand position. The results show that this criteria provided 100% accuracy for 3 positions. In part of template dataset, we can discuss that the variation of the hands and the dataset of this study templates was small. This may be result from the age range. This study collects the image from students who aged between 19 to 22 years old. For the criteria 1, each input image will be matched mostly with template group that is similar with itself. The percentage of accuracy indicated that these criterions worked well for lateral images, but not so well when applied with the PA images. The CC value of 7.5 was used as the optimal threshold. From our results, these methods worked well with oblique and lateral input images. By using number of fingertips, the accuracy of image matching are 100% for all 3 input images, so the method worked well with all positions. However, there are some limitations in this study. The error can caused by the process of image acquisition. Taking images with insufficient light may poor image quality that have shadows around hand. In the pre-processing step, the program could not separate hand and shadow. In addition, background used for taking image should be dark to improve the contrast between the hand and background. From our results, we can conclude that the counting fingertip is the best choice of image matching criterion comparing to others. And we can apply this method to improve the cheating process for self-learning and the X-ray simulator. I would like to thank my advisor, Assistant Professor Yuttapon V. Chian-in, my co-advisors, Associate Professor Jirapon Dojaranchai, and Professor Junji Morishita. Thank you, Faculty of Medicine and Technology. Oh, sorry. Thank you Faculty of Medical Technology, Mahidol University, and Department of Health Sciences, Faculty of Medical Sciences, Kyushu University for the knowledge given. Thank you again for your attention.